sketching the graph of a function. So we have this equation here, and the first thing is to identify that it is a linear function, or the formula of a straight line. How do we know that? Well, y to the power of 1 and x to the power of 1. So that guarantees it's not a quadratic x squared or a parabola. It's not a cubic x cubed. It's x to the power of 1. But if that is what indicates it is a linear equation, we should write it in the generic format, which is always y equals mx plus c. So that's the first thing we have to do with this black equation. So keep the y there on the left hand side, and to eliminate the negative 2x, all we need to do here is add 2x to both sides of the equation. So on the left hand side, 2x minus 2x is 0 and disappears. On the right hand side, we have 3 plus 2x. We can even rewrite this to look like the gray one: 2x, x term at the front, plus 3 independent term at the end. So now let's talk about that m. M is the gradient, the number in front of x. So in our case here, m is 2. And the gradient is also seen as the rise over run. Rise meaning the vertical shift, and run meaning the horizontal shift. It could be up or down, or a left, right. We'll see what happens here. So in this example, the gradient is 2, but we need to see this as a fraction so we can have a number for the run as well. So that number on the bottom will have to be invisible 1, but we need to make it really clear. So we know we are going to go 2 units up because it's positive. If we had negative 2, to go 2 units down. And we're going to go across to the right 1 unit, again, because it's positive, we're going to the right. If we had a negative number, we would go to the left. Before we get started in sketching the graph, let's look at what that value of c is going to tell us. C is the y-intercept, meaning every time it crosses y, x is 0. And if x is 0, all that expression mx is gone, and y equals c. So let's even just write here y-intercept. So now what we need to do is draw a set of axes, the vertical axis y, the horizontal axis x. And then we start, as we said, with the y-intercept. Oh, maybe before we can just put a few ticks. So they should be the same length, but let's just put a few ticks to get started. We don't know what we're going to need. Good. Let's go back to that idea. Now, y-intercept, we said, was 3, the value of c. So in the y-axis, we count 1, 2, 3, and place the big dot there. Then we have to remember that our gradient, or m, was 2. But we also talked about looking at that as a fraction, 2 over 1. So we know that from this green y-intercept, we have to go up 2 units. So let's go up to unit 1, 2. So we are actually now on 5, because we went 3, 4, 5. And we have to go across 1 unit. So I'm going across this distance here. Just repeating then. Go up 2 and across 1. So wherever we end there, that second arrow, that is not the gradient, but that's the second point we have. I'm making it in blue. So the gradient doesn't appear in the graph, because here the coordinate is 1, 5. So that blue point has coordinates x1 and y5. Always x followed by y. The green point has coordinates. The x is 0 and the y is 3. but the 2 doesn't appear in those points. So the gradient is just a way to get to a point, not the point coordinates themselves. So now all we need to do is get a ruler if we can and draw a line going through those points. Never stop at the points. Make your line free and going through the points. So this is the formula, or original formula we had, sketched into a graph, a straight line.